transforming to a triple integral, we need to evaluate this surface integral, where S is the closed surface bounded by the planes z equal to 0, z equal to b, and the cylinder x² plus y² equal to a square. So we can use the Gauss's Divergence Theorem over here. We have x² plus y² equal to a square and z equal to 0 and z equal to b, right? The planes. So by Gauss's Divergence Theorem, we know that this surface integral is equal to the volume integral of this given vector is equal to the volume integral of the partial derivative of first component, that is x³ with respect to x, plus the partial derivative of second component, that is x²y with respect to y, plus the partial derivative of third component with respect to z, that is x²z dv. So this is equal to the volume integral of, derivating x³ with respect to x, we get 3x² plus from the second term we get x², from the last term we get again x² dv. So that is equal to 3x² plus x² plus x², which is 5x². Now we are taking the triple integral because it is your volume integral which is changed into the triple integral, and the integrand is 5x² and dv is changed into dx, dy, dz. And we need to write the limits for x, for y and for z, right? Okay. We have x² plus y² equal to a square, that is given to us. From here I can get y² to be equal to a² minus x², and we can take the limits of y to be plus minus square root of a² minus x². Because I am having the value of y in terms of x, so can I write this dy first over here? If dy written in the first place, that means you have to get the limits of y in terms of x, right? For two variable equation, if dx would written first over here, then you need to get the values of x in terms of y, right? And because I'm having the value of y in terms of x, that is why I have interchanged dx with dy. I hope it is clear to you, right? So writing the limits for y as negative square root of a² minus x² and positive square root of a² minus x². Limits of z already given to us, which are constant. And now writing the limits of x. Now limits of x should be in terms of z. But because we are having the two variable equation, so there is no z in this equation. So what we are going to do is, because the integration with respect to y is over, right? So the limits of x should not dependent upon y, right? So that is why we need to take y equal to 0 in this equation, and from here we get x² equal to a², and the limits of x becomes plus minus a. Very fine. Okay, so writing here negative a to a for the limits of x, and limits of z, it is given to us that z is equal to 0, z equal to b. So using the limits of z as from 0 to b. Okay, fine. Alright. First we need to integrate with respect to y. So for this integration, 5x² is constant, right? So taking 5x² outside of this integral and integrating 1 with respect to y. So that gives y. When putting the upper limit, we get square root of a² minus x² minus, putting the lower limit, we get negative of square root of a² minus x². That becomes twice of square root of a² minus x². Fine. And also 5x² is multiplied with this as a constant, right? So this is 5x². I'm writing twice outside of the integrals, and this is square root of a² minus x² dx dz. And now integrating this with respect to x, because this is your even function, so the integral becomes twice the integration from 0 to a, 5x² square root of a² minus x² dx dz, right? Whenever you are having the even function with opposite limits, the integration is changed into twice the integral of the integrand, but the limit should be from 0 to a. If it is the odd function, the integration will become 0. So taking this 2 outside of this integral, which becomes 4, and also taking this 5 outside of this integral, which becomes 4 into 5, 20. And now we need to integrate this with respect to x. And now integrating this with respect to x. For that, let's use the substitution method. Just put x equal to a sine of theta, and you get dx to be equal to a cos of theta d theta. When x equal to 0 for the lower limit, theta becomes 0. And for x equal to a, just put a over here, you get sine theta equal to 1, so theta becomes pi by 2. So this is equal to 20, integration 0 to b, and here the limits changed into 0 to pi by 2. And x square becomes a square sine square theta. So this is square root of a square minus x is a sine theta, so it is a square sine square theta. So this is square root of a square into 1 minus sine square theta. That is square root of a square into cos square theta, which becomes, because of the square root, it is a cos of theta. So writing here a cos of theta, and dx becomes a cos theta d theta. So I'm having a into a, that is a square, multiplied with this a square, that becomes a to the power 4. And taking this a to the power 4 outside of the integral. And inside we are having sine square theta cos square theta d theta dz. I'm going to use the reduction method over here now. So this is equal to 20 a to the power 4 integration 0 to b. Okay, integrating this with respect to theta, but using the reduction method. What is the power of sine? What is the power of sine? It is 2. So we need to subtract the odd numbers from this power until we get 1. So 2 minus 1 is 1. Into, what is the power of cos? It is again 2. So we need to subtract the odd number from this power. So 2 minus 1, 1. Right? Divided by, take the sum of the powers, that is 4. Write down 4 over here. And then we need to subtract the even numbers from the sum. So 4 minus 2 is 2. And 4 minus 4 is 0. You don't need to write 0 over here, because we only need to subtract the numbers until we get 1. One thing more, whenever you are having the even numbers in the powers, we always multiply the result with pi by 2. Right? Okay. So from here we get, in the denominator, 4 into 2 into 2, that is 16. So taking 16 outside. So this is 20 a to the power 4 divided by 16. And integration from 0 to b. Wait. I must write dz over here. Thank you. So this is pi dz. You can also take pi outside of this integral. So this is 20 pi, and integrating 1 with respect to z. So this is 5 and this is 4. 5 divided by 4 pi a to the power 4, and integrating this we get z limits from 0 to b. So that is equal to 5 divided by 4 pi a to the power 4. Putting the upper limit we get b, minus putting the lower limit we get 0, that becomes b only. So this is the required answer for the given integral. Alright, thank you. And now time for the thought of the day. How people think of you is influenced by how you think about yourself. If you think negative about yourself, that means you are creating a negative aura around yourself. So if you think positive about yourself, you are creating a positive aura around yourself, which is radiated into the environment. So always be positive and believe in yourself. Thank you.